In a recent video, I went through the science of marathon running and carbohydrate loading. And one of the big determinants of how much carbohydrate an athlete should eat before the race is how hard they're working during the course of the marathon at a relative intensity. How do we figure that out? In this video, we're going to go through some easy ways to calculate your percent of VO2 max so you can get a better idea about how much carbohydrate you want to eat in the days leading up to your race. So the first part of the equation we need to figure out in terms of relative intensity is your VO2 max, or the maximum amount of oxygen that you can consume on a per minute basis relative to your body size. There's a few different ways to do this, from very complicated and expensive to very cheap and straightforward. We'll start off with the more complicated option first, which is to go into a laboratory and actually get your VO2 max assessed directly with metabolic equipment. Now, this is a very accurate way to do it. My laboratory does this sort of testing on a regular basis. I've probably done 150 to 200 of these tests over the last decade. And it's the gold standard in terms of determining VO2 max. On the downside, it is a more expensive option. It's going to set you back probably $100 to $200. And the other thing is that you have a mask on. The first time somebody does this, they're oftentimes nervous. And those are factors that can kind of contribute to maybe quitting before you actually reach your VO2 max. It depends on the athlete, depends on how uncomfortable they are with something on their face, how anxious they are going into the test. But it may actually take a couple of tests before an athlete would really achieve their true VO2 max because of those types of issues. Nonetheless, it's a very accurate way of getting your VO2 max. Now, option number two would be to use something like a wearable device. Like my Garmin watch here, it spits out a VO2 max estimate. And to be honest, it's pretty decent for most people. And I can back that up with a couple of sources of information. The first being a study here as an example, looking at the Garmin 245, Forerunner 245, showing that for most people, it gets you within 5 to 10% of your true value. What you see in this graph is on the horizontal axis, you've got average VO2 between the two methods. So the Garmin estimate and then an actual laboratory measurement. And then on the vertical axis, you've got the difference, the individual differences between the two for each person in the study. So each dot represents a person. So you can kind of see the closer those dots are to the line 0, that would mean there's no difference between the two methods, essentially. The dots getting farther away from the 0 horizontal line means there's a bigger difference between the two methodologies. And you can see for most people, they're within 5 milliliters per kilogram per minute of the actual true value when you look at the Garmin watch. So not too bad. That's around, within about 10% for most people of the true value. Now, that's not perfect, but it is something that, isn't terribly expensive. And again, you're going to have that watch for, years probably. So it provides a way to continually look at your VO2 max, whereas a laboratory test, every time you go in, is going to be $100 to $200. So in the long run, the watch is probably going to be a less expensive investment, albeit with a little bit more error than what you get with the laboratory-based testing. Now, the third option we're going to talk about here with getting an estimate of your VO2 max is to just do a field test. You go out, you run a standard distance, you plug in the numbers from the test, and it spits out an estimate of your VO2 max. One of the most common ways or common tests is the 1.5 mile maximal run. So you go out, adequately warm up, you do the 1.5 mile run, preferably on a track, so you know it's the exact distance, and you record your time. An example here is a website, exrx.net, which has a calculator where you can plug in that time into their calculator, and it'll spit out a VO2 max estimate. So in this case, I used what I would think to be my current 1.5 mile time. I didn't actually go out and do this, But I had a maximal mile back this summer, which I did in 5:02, recent 5Ks in the 1740s. So I put in 8 minutes and 15 seconds as my estimate for my mile and a half run. It estimated my VO2 max to be 62. Now, how does that compare to my Garmin watch? My Garmin watch says my VO2 max is 60. How do those compare to an actual laboratory test? When I've done that in the last half year, I'm kind of in the mid 50s, perhaps high 50s on the right day, and if the protocol suits me. So they're all within about, again, 10% of each other, no matter what methodology that I'm using. So you can go again from something very complicated and expensive like a laboratory test to something very straightforward. All you need is a timer. You need somewhere to run a mile and a half. You got to put the effort into it and do it maximally. But it gets most people within, probably 10% of their true value. Okay, now that you have your VO2 max number, what do you do next? Well, if you're planning to run marathon, you need to kind of know what approximately are you going to be doing in terms of your pace. The reason why we want to know that is because there's a pretty predictable relationship between running velocity and oxygen consumption. So this is just an example from one study, and there's been many of these studies that have looked at this relationship between velocity of running and volume of oxygen consumed. And you can kind of see there's a pretty tight positive relationship between the two. As velocity goes up, VO2 goes up. So if we know what an athlete's running pace or projected running pace during the marathon is going to be, we can get a reasonable estimate of their oxygen consumption. So if you're thinking about running a marathon, I've got a table here that lays out sort of marathon times and how that translates to speed in miles per hour, in meters per minute, and then estimates of VO2 based on three different formulas. So there's a formula called the Mayhew, there's a Daniels formula, which is a Jack Daniels equation, and then an ACSM formula, which is the American College of Sports Medicine. Now, no matter what formula you look at here, they're all reasonably close to one another. The ACSM equation tends to have a little bit of a higher estimate than the other two, but it's not grossly different. Now, the ACSM equation might be more suitable for beginning runners, runners that aren't as trained, whereas the Mayhew and the Daniels formulas are probably better for runners who are more experienced, who are more economical. You can kind of see the VO2 values are lower for a given speed with those formulas than the ACSM equation. So more experienced runners, higher level runners are more economical. They use less oxygen at a given speed. So that's why those two equations would be maybe more appropriate for an athlete who's higher caliber. But nonetheless, all these equations come up with relatively similar estimates of oxygen consumption for a given speed. So let's say I'm shooting for a 2:55 marathon. I know my VO2 max is anywhere from 58 to 62 based on laboratory method, Garmin watch, and the 1.5 mile maximal run. So if I look at the table here, 2:55 marathon is roughly equal to anywhere from 45 to 52, and that's in milliliters per kilogram per minute in terms of oxygen consumption. I'm going to use the 47 value just because it's kind of in the middle of those three estimates. So if I take 47 and I divide that by my three VO2 max estimates, so 58, 60, and 62, I get a range of anywhere from 76 to 81% of VO2 max. So I would be projected during the marathon to be working at anywhere from around 76% to 81% of my VO2 max. Now, if we go back and talk about how that relates to carbohydrate recommendations, you can kind of see the graph here. If you look between the two bar graphs that say 70% and 80%, that's kind of where I'm at. And if we go over to the vertical axis, that's saying I should probably ingest somewhere in the range of maybe 6.5 to 8.5 grams of carbohydrate per kilogram of my body mass per day. That could be starting a couple of days before the marathon, for example. If I got a marathon on Sunday, maybe I'm eating that quantity on Friday, maybe doing a little bit less on Sunday because I don't want to overdo it the day beforehand. But that's kind of the total amounts. So if I'm, for example, targeting 8 grams per kilogram of my body mass, and I'm a little under 80 kilograms, but let's just for the sake of ease, say I weigh 80 kilograms. 8 times 80 is 640. That's roughly the amount of carbohydrate I would want to consume in a day leading up to the marathon. Again, for example, maybe starting 2 days beforehand, doing a little bit less the day beforehand with the idea that I don't want to necessarily overload my body and my gut. All right, to sum up, what we need to again know is your VO2 max. You can get that from a laboratory test, a wearable watch. You can get it from a field test like the 1.5 mile run. And once you have that estimate, all you need to know next is what am I expecting to compete at or race at during the marathon? What's my pace? You can get a VO2 or an oxygen consumption associated with that running speed divided by your VO2 max. That tells you roughly what relative percentage of your VO2 max you're expected to work at during the course of that marathon. And that's going to be hopefully informative for determining whether or not you really need to up the carbohydrate intake beforehand. The higher the percentage of VO2 max you're working at, the more carbohydrate you're likely to need to load up with before that race starts.